So at this point, we have learned five different ways for proving that two triangles are congruent. Let's just review those real quick. They were S, 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 A, S, A, S, A, AAS, and HL, right? And each of these involve us having kind of three pieces of evidence that would let us demonstrate that two triangles in a diagram are congruent to each other. For this video, we're not going to learn anything new to add to this list, but what we are going to look at is maybe a different kind of scenario where the triangles that we're trying to prove congruent are overlapping each other. So we're going to be looking at congruence in overlapping triangles. And let's start by looking at this diagram here and listing the corresponding parts of triangle ABC and triangle DCB in this diagram. So first, I just want to kind of highlight the two triangles that we're talking about here. It would be triangle ABC, so I'm going to highlight that. It's kind of yellow color here, triangle ABC. And then triangle DCB we'll highlight in this green color here, DC, and over to B, and then back up to D. And so you can see why these are considered overlapping triangles. There's this portion right here that's kind of like, this part of this diagram is a part of both triangles, triangle ACB and triangle DCB. So let's just first list out the corresponding sides between these triangles. In other words, if I look at one side of triangle ABC, side AB, what side of triangle DCB appears to be kind of matching that? Well, it would be segment DC, right? So segment AB and segment DC match each other. Then we can look at segment AC, and it would be corresponding to segment DB. They kind of match each other in terms of where they are in these triangles and kind of, I guess, the role they're playing. These are both right triangles. Each of those is a hypotenuse. So those correspond to each other. And then finally, the third side of triangle ABC would be segment BC. It goes from the vertex of the right angle out to this corner of triangle ABC. But that segment BC would correspond to the segment that does the same thing in triangle DCB. Starts at the vertex of the right angle and goes out here to one of the other corners, and that's segment CB. Now you notice I could have written this one as segment BC as well, so we'd have BC and BC, but by writing it as CB, kind of switching those letters around, it kind of indicates that the B in triangle ABC is corresponding to point C in triangle DCB, right? B is first and C is first here. Now let's go ahead and list out the corresponding angles. We can see they both have a right angle, so we could say angle ABC. I'm going to use the three-letter names since just saying angle B might not be specific enough. Angle ABC would correspond to angle DCB. This angle up here, angle BAC, would correspond to this angle right here, angle CDB. And finally, this angle in triangle ACB, which would be angle ACB, would correspond to this angle right here, which would be angle DBC. So we have our three pairs of corresponding sides and our three pairs of corresponding angles. Now the next thing we're going to look at is which of those pairs of corresponding parts are congruent, and with that information, would the two triangles be congruent? So for this, I'm going to real quick sketch out these two triangles separately down here. So I'm going to try sketch out triangle ABC here, right? So I got point A, point B, point C. I see that there's a right angle marked there, and there's this side marked congruent there. And then I'm going to sketch out triangle DCB. It's going to look like this. DCB, and I got a right angle here, and I got this side marked congruent. So I can see that segment AB and segment DC are congruent to each other. Right? Segment AB is congruent to segment DC. I can see that angle ABC and angle DCB are congruent, so that's this one right here. Angle ABC is congruent to angle DCB. They're both right angles. And then I might notice that this pair of parts right here would actually be considered congruent because they are technically the same segment. So angle B, not angle, that would be segment BC is congruent to segment CB, and that's by the reflexive property. So just to give some reasons, that's given, or we could say all right angles are congruent, and this is true by the reflexive property. So are these two triangles congruent? Yes. Triangle ABC is congruent to triangle DCB by side, angle, side. We can see we have two pairs of sides and a pair of included angles. And so that's the kind of situation that we'll be looking at in this section, where we have a couple of overlapping triangles that may be congruent because perhaps they're sharing a pair of parts, or maybe there's some other reasons why they might be congruent. Maybe they don't necessarily share a pair of parts, but maybe there's something else happening in the diagram that lets us say a pair of parts are congruent for one reason or another. So the next thing we're going to look at is three diagrams where I'm going to kind of ask you to look at a couple triangles and identify what sides or angles are shared by those two triangles. So to start with, let's look at triangle BFE. I'm going to highlight it, triangle BFE right here, and triangle CEF. CEF. And the question is, what pair of parts do those two triangles share? We can see here they share this segment FE. They share segment FE. And the next triangles, the next set of triangles, the next diagram, we're looking at triangle FJH. So F over to J, up to H, back to F. And triangle KGH. So K over to G, up to H, and back to K. Let's see if I can do that one. There we go. And these two triangles, they don't share any sides. We can see segment HG, it's a side of the green triangle, but it's only part of the side of the yellow triangle. Segment HJ is an entire side of the yellow triangle, but only part of the side of the green triangle. And then the other sides, they're not shared between the two triangles. So these two triangles don't share a side. What they share is actually this angle right here, angle FHK, or we could just say angle H. Angle H is in both triangles. So that is considered a shared part. Then we have the last one here. It looks at triangle WST. So W to S over to T, back to W, and triangle VTS. That would be this one. What do they share? Well, we can see that they share from S all the way over to T. That is a side right here. That's a side of both triangles. So they share segment ST. Now, in the example problems for this video, we're going to look at a couple of these diagrams. I believe it's these two diagrams, and we're going to look at why there might be some congruent triangles in these diagrams, perhaps based on what we just observed about the parts that they share. This last bit on this note sheet, though, says overlapping triangles in the segment addition postulate. Let's recall real quick what the segment addition postulate says. The segment addition postulate, something we learned a while ago. It was one of the very first things we learned, really. It looks at a diagram where maybe we have a segment called segment AC. And we can look at the length of AC and we can maybe measure it. Maybe we grab a ruler and measure out how many centimeters long it is or something like that. But then maybe we put another point right about here, call it point B. If I was to measure from A to B, and then I was measuring from B to C, right? So I get a measurement here and a measurement here. Those two measurements, if I add them together, should give me the same measurement as I had for the entire segment AC, right? So the segment addition postulate is that idea, that the length of AC in this picture right here would be equal to the length of AB plus the length of BC. Now we're going to see how that might apply in a diagram like what we see here, where it's asking us, are AE, let's just highlight that, AE, is that the same length as DF? And we can see that those two segments are not marked as the same length. Part of segment AE, right, from A to F, is marked congruent to part of segment DF that goes from D to E, right? AF is equal in length to DE. And then, of course, there is some overlap between these two segments. They overlap right here in segment FE. So we're going to apply the segment addition postulate, and we're going to show how, based on what we just observed, these two segments, AE and DF, must be congruent in length. And we're going to kind of go through a detailed explanation using this segment addition postulate. So it's going to say this. Already we're going to go ahead and say that segment AF is congruent to, or is equal in length to segment DE. We're also going to say that AE is equal to the length from AF plus the length from FE. And then DF is equal to the length from D to E plus the length from F to E. But since right here, this AF is equal to a DE, right? That means that I could take AF right here and substitute DE in its place because they're equal to each other. So I can say, therefore, AE equals DE plus FE, which is the same thing as DF, right? AE can be explained as DE plus FE, and DF is also DE plus FE. So that means AE must be congruent to DF. Segment AE must be congruent to segment DF because they both equal the distance from D to E plus the distance from F to E. And what we're going to see is in some problems, like maybe some of the examples that we see up here, this idea might allow us to prove perhaps that a couple triangles are congruent. For instance, if you look at this diagram right here, and you look at triangle ABE and triangle CDF, I already can see that they have a pair of sides congruent there and a pair of angles congruent there. And then according to what we just explained here, this side is congruent to this side, which would let us say that triangle ABE must be congruent to triangle DCF by side angle side, because of the markings that were already there, plus this reasoning that I explained over here, giving us our third pair of sides, our third piece of evidence, I guess you would say. So that's the idea that we're going to be looking at with these overlapping triangles. Sometimes they're going to share parts. Sometimes there's going to be parts of them congruent based on an idea like the segment addition postulate.